Welcome to today's ArXiv CS Digest for April 29th, 2026. We received 604 new computer science papers today across 58 subfields. Let's dive into the top picks. Trend 1 of 5, Shape-Constrained Learning in Networks. These papers explore learning algorithms and network architectures that incorporate structural or functional constraints for improved performance and guarantees. This cluster covers 122 papers. Representative work includes hyper-input convex neural networks for shape-constrained learning and optimal transport, learning over relaxation policies for ADMM with convergence guarantees, and adaptive self-organization in anonymous dynamic networks. Trend 2 of 5, 3D reconstruction and vision navigation. These papers explore creating and navigating 3D representations of the world using visual data and advanced AI. This cluster covers 157 papers. Representative work includes entire 2026 3D restoration and reconstruction in real-world adverse conditions, RealX 3D challenge results, 3-step nav, a hierarchical global local planner for zero-shot vision and language navigation, and World 2 VLM, distilling world model imagination into VLMs for dynamic spatial reasoning. Trend 3 of 5, mathematical models and quantum computing. This trend explores advanced mathematical modeling and computational techniques, including quantum computing, to solve complex problems across diverse fields. This cluster covers 73 papers. Representative work includes fractions of recurrence operators for generalized Fourier series in classical orthogonal polynomials. Degree-dependent and distance-dependent contact rates interpolate between explosive, exponential, and polynomial epidemic growth, and exact dynamic programming for Sokolowski diversity subset selection on lines and staircases. Trend 4 of 5, LLM evaluation and question answering. This trend focuses on improving LLM capabilities and reliability through advanced evaluation, question answering, and robust deployment strategies. This cluster covers 140 papers. Representative work includes Turning the Tide, cross-architecture distillation for diffusion large language models, a decision-theoretic formalization of steganography with applications to LLM monitoring, and AutoArgue, LLM-based report generation evaluation. Trend 5 of 5, AI agents and code generation. These papers explore AI agents automating code generation, evaluation, and deployment for diverse applications. This cluster covers 112 papers. Representative work includes ProcFunc, function-oriented abstractions for procedural 3D generation in Python, Select to Think, unlocking SLM potential with local sufficiency, and artistic practice opportunities in CST evaluations, a longitudinal group deployment of ArXiv. Up next, our first paper out of 5, Agentic fusion of large atomic and language models to accelerate superconductors discovery by Mingzi Li and Wenbing Huang from Renmin University of China. Let's break down its key contributions. Introduces Elements Claw, an agentic framework that integrates large atomic models, LAMs, and large language models, LLMs, to autonomously orchestrate the materials discovery process. Demonstrates the framework's effectiveness by guiding the experimental synthesis of 4 new superconductors and identifying 68,000 high-confidence superconducting candidates from over 2.4 million crystals. Leverages LAMs for atomic-scale computation and LLMs for semantic reasoning, enabling a shift from isolated AI processes to integrated human interactive materials discovery. Up next, our second paper out of 5, Provable coordination for LLM agents via message sequence charts by Benedict Bolig and Thomas Nowak from Université Paris-Saclay, CNRS, INS Paris-Saclay, LMF, GIF-sur-Yvette, France. Let's break down its key contributions. Introduces a new language based on message sequence charts, MSCs, to specify agent coordination, separating structure from LLM actions. Presents a syntax-directed projection that generates deadlock-free local agent programs from global coordination specifications. Describes a runtime extension where LLMs dynamically generate coordination workflows with guaranteed structural properties. Up next, our third paper out of 5, Adaptive Layerwise Perturbation, Unifying Off-Policy Corrections for LLM-RL by Chenlu Yi and Tong Zhang from University of Illinois, Urbana-Champaign. Let's break down its key contributions. Introduces ALP, a novel method that injects learnable perturbations into hidden states of each layer during updates to mitigate off-policy issues in LLMRL. ALP unifies off-policy corrections by preventing the updated policy from deviating too sharply from the inference policy, thereby reducing the tail of importance ratios and maintaining training stability. Empirically demonstrates that ALP improves final performance, avoids KL spikes, and boosts exploration on math and tool-integrated reasoning tasks. Up next, our fourth paper out of 5, a survey of process reward models. From outcome signals to process supervisions for large language models by Tsongmin Zheng and Weinan Zhang from Shanghai Jiaotong University. Let's break down its key contributions. This survey provides a comprehensive overview of process reward models, PRMs, covering their entire life cycle from data generation to application in reinforcement learning and test time scaling. The paper highlights the limitations of traditional outcome-based reward models and introduces PRMs as a method to evaluate and guide LLM reasoning at a more granular, step-by-step level. By clarifying design spaces, identifying open challenges, and summarizing applications across diverse domains, this survey aims to steer future research towards more fine-grained and robust reasoning alignment for LLMs. Up next, our fifth paper out of 5. Cognitive Atrophy and Systemic Collapse in AI-Dependent Software Engineering by Frank Jinak from Georgia Institute of Technology. Let's break down its key contributions. Defines epistemological debt as the hidden cost of engineers relying on AI verification over logical derivation, leading to eroded mental models. Highlights how recursive training on synthetic code leads to mechanized convergence, reducing software diversity and increasing systemic fragility. Advocates for rigorous human-in-the-loop pedagogical standards to balance AI productivity with the epistemic sovereignty needed for managing complex software. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.